Okay, today in this video, we're going to have a little blast from the trigonometry past and look at one of the questions from that last page of one of the practice sheets I gave you that I said, hey, this is extension 4 now. But now you have those skills that you should be able to go back and do them with your factoring skills. So I'm going to share the screen. I don't have a copy of that booklet, but it doesn't have writing all over it. So I'm just going to write it up here. So I'm going to do 5D from that worksheet. If you don't know what that worksheet is, or you have no idea what I'm talking about, or you handed it in and you don't have it, because I have it, here's the question, and you can pause the video and then try it. So it's 6 cos squared theta minus cos theta minus 1 equals 0. Okay, so pause the video and give that a try using U-substitution. No, I do not want to do that. Leave that there. Okay, so for this, we're going to let U equal cos theta. Now, one of the students asked me, why is it cos squared theta, not cos squared theta squared? Or cos theta squared? Very good question. It's just because it is. Technically, it's cos theta and the whole thing is squared, but we just write it like, oops, no. We just write it like this. Sorry, something's happening over there and I'm trying to ignore it and keep going. Okay, so I'm going to rewrite this, but instead of writing cos theta, I'm going to write a U. So this is going to become 6U squared. Remembering that that's kind of weird how we write cos theta squared. The square is on the cos, not the theta symbol. It's just some person at some point decided that's how we were going to write it. Minus cos theta, which is a U, minus 1 equals 0. So for this trinomial, you have a 6 in the A position, so you cannot just use the product sum method, you have to use decomp or box method. So you're looking for two numbers that multiply to give you -6. And those same two numbers have to add to give you a -1. Okay. So if you were stuck on that part, pause the video now and give that a try. Okay, so the two numbers are -3 and +2. So, because -3 times +2 is -6, and -3 plus 2 is -1. So now we're going to factor by grouping, or we use decomp method, which requires factoring by grouping, and we're going to factor the first two terms. There is a 3 and a U common with both of them. And we're going to factor that second one. Now, we're going to use the symbol that's in front of the first term, which is positive. And there's no large number that goes into 2 and 1. So the number, if you can't think of a number because there is no number, it's 1. And we're going to get 2U minus 1 equals 0. So we got 2U minus 1. That's common in both those megaterms. So we're going to factor out 2U minus 1. And that's going to leave us with what's left. And that is 3U plus 1. And this is where we're going to solve. And we're going to actually practice the solving stuff even more with quadratics. But right now, the whole thing has to equal to 0. So there's two possibilities. There is 2U minus 1 equals 0. Because if this first bracket equals 0, it doesn't matter what the second bracket is, because anything times 0 is 0. And then the second possibility is if the second bracket is 0, because again, it doesn't matter what the first bracket equals to. If 3U plus 1 is equal to 0, anything times 0 is 0. Okay. So we can solve for U in both of these options. So we're going to add 1 to both sides. We get 2U equals 1, divide by 2, and we get U equals 1/2. And we do the same thing on this side. We have minus 1 on both sides. We get 3u equals negative 1. Divide both sides by 3, and we get u equals negative 1/3. Okay. Now from here, we've gone all the way we can go with u. Pun not intended. All right, so we're going to now put back cos theta in for u. So I'm going to rewrite these. Instead of writing u, I'm going to write cos theta equals 1/2. And over here, I'm going to write cos theta equals negative 1/3. Okay. Now, the first one is a special ratio, a special triangle ratio. It's one of those ones that you could either just memorize, or you could use the hand method, right? But your reference angle, if cos theta equals 1/2, your reference angle is going to be 60 degrees. Okay. Now this ratio, this cos theta ratio is positive, which means that your cos, if you remember cast, cos is positive in 2 quadrants, right? And if the reference angle is 60 and it is in the those two quadrants, the first quadrant, the standard angle is going to be 60 degrees. And in the fourth quadrant, it's going to be 360 degrees minus your reference angle, which is 60 degrees. So your other angle is going to be 300 degrees. Okay, so those are 2 possibilities that will work. Okay. And now we're going to do the other. Now, cos theta equaling negative 1/3 is not a special ratio that you learned. It's not one of the special triangles, sorry, that you learned. So that's going to be a decimal. And this worksheet asked for answers to be rounded 2 decimal places if they had them. So if you just plug in negative 1/3, you hit equals, and you hit second function cos, so you're using inverse cos, theta is going to equal the inverse cos of negative 1/3, and you get that your reference angle, because remember that's always going to give you that, if you put it in your calculator as negative 1/3, it's going to give you only one of the standard angles. So I actually, remember in class, advised you to actually just do the absolute value of the ratio so that you get the reference angle, and then you can decide which is the standard angle. So if you do positive 1/3, you're going to get the reference angle of 70.53. Okay. But the actual cos theta ratio was negative. So cos is negative where it's not positive. We already know where it's positive. I already highlighted that in green. So where it's negative is where it's not positive. It's negative in the second and third quadrant. So to get the theta, the actual angle, standard angle in the second quadrant, you're going to take 180 degrees and subtract the reference angle, and you're going to get 109.47 degrees. And had you put in the inverse cos of negative 1/3 back at this step, you would have gotten this answer. The problem with that, though, is you still have to calculate the reference angle to get the other answer, which is in the third quadrant. So to get the standard angle in the third quadrant, you're going to take 180 and you're going to add the reference angle. So if you take 180 and you add the reference angle, you're going to get 250.53 degrees. So that's it. Those are your 4 reference angles. If you were to put those angles in for theta in that original equation that you were given, so you did cos of 60 degrees, you squared it, you multiplied it by 6, and then you subtracted cos of 60 degrees and then subtracted 1, you would get 0. And if you repeated it with all of them, you would get 0 for all of them. That's a way of checking your answer. So best practice is always to write out your answer in numerical order. And then because you really want me to be able to see where your final answer is on a page that might be a little bit messy, something like mine, you put a little box around it. So hopefully that helped. Let me know if you have any questions. Welcome to the blast from your trigonometry past.